Mr. Corsi here. In this video we're going to explore the effect of dividing one complex number, say z1, by another complex number, z2. What's the geometric effect of that division? Well, if z2 is 1 and we divide z1 by 1, z1's not going to be affected at all. There's the result. It's identical to z1. If instead we divide z1 by 2, then we notice that its modulus has been halved. It's been scaled by a factor of 1 over 2. Remember, 1 over 2 is a multiplicative inverse of 2. And similarly, if we divide it by 3, the modulus has been scaled by a factor of 1/3. The multiplicative inverse, or the reciprocal as it's sometimes called, the reciprocal of 3 is 1/3. And remember, you can compare that with multiplication, which remember did the, if you like, the opposite. When you multiplied, there was a scaling of 2 when you multiply by 2, and a scaling of 3 when you multiply by 3. Let's now bring the argument into play. So we're looking at the effect on z1 of dividing it by 2i. And I think to begin with we would suspect therefore that since the modulus of 2i is 2, z1 probably is going to be scaled by a factor of a half and scaled towards the origin. So let's have a look and see what's happened. And there it is. That looks pretty much like a half for a half of the original modulus for the modulus of z1 over z2. But look at the argument. Now z2 has an argument of pi upon 2. And you'll notice that z1 has been rotated, but in a negative direction by an angle of pi upon 2. So whereas the argument of z2, principal value of the argument of z2 is a positive pi upon 2, the rotation on z1 is the negative of arg z2, or negative pi upon 2. So let's look at a different situation where we're taking z1 and we're dividing it by negative 2i. And see if we can predict what's going on. Probably a scaling of 1 over 2, since the argument, the modulus of negative 2i is 2, so a scaling of a half. And this time the argument of z2 is negative pi upon 2, so we'll probably get the additive inverse of that, which is positive pi upon 2 for the rotation. So let's check if that's the case, and I think we've been proved right there. There's z1 divided by negative 2i, z1 divided by z2. The rotation is positive pi upon 2 when the argument of z2 is negative pi upon 2. So it's the negative of the argument of z2 that we use for the rotation. And the scaling is, as we suspected, is 1/2, 1 over the modulus of negative 2i. So let's try and summarise what we've observed so far. So we'll put in this table the geometric effect on z1. First of all, in the top row of multiplying by z2, and in the second row the effect of dividing by z2. So it's what happens to z1 when we multiply by z2 and divide by z2. So first of all, multiplying by z2, then z1 would be scaled by a factor of the modulus of z2, and if we divide by z2 it would be scaled by a factor of 1 divided by the modulus of z2. Now that's the multiplicative inverse, or the reciprocal of z2, modulus of z2. And then if we move to rotations, if we multiply by z2, then z1 will be rotated about the origin through an angle of arg z2. That's the principal value of the argument of z2. And if we divide by z2, it'll be rotated about O through principal value negative of the principal value of z2. That's the additive inverse, or the negative of the principal value of the argument of z2. Now, two situations arise in each case. Suppose the argument of z2 is positive and we're multiplying by it. That's a positive rotation. It'll be in an anti-clockwise direction. And if the principal value of the argument of z2 is less than 0, that's a negative rotation if we're multiplying by z2, and that will go in a clockwise direction. And the opposites will be true for division. If arg z2 is positive, then we get a negative rotation, which will be a clockwise rotation. And if arg z2 is negative, then the negative of that will be positive, so it will be an anti-clockwise rotation. So that's a summary of the effects on z1 of multiplying and dividing by z2. So it's now time for you to tackle a problem. So I'd encourage you to stop the video at this point and see if you can attempt this example, 3 parts of this example. So let's have a look at part A. Now, the first thing we'll need to do is to decide what effect multiplying by 1 plus I has on a complex number. So let's try and find the argument and the modulus of this. Now, right angled triangle, 1 along, 1 up, root 2 for the modulus, and the principal value obviously is pi upon 4 from the diagram. So the arg 1 plus I is pi upon 4. So multiplying by 1 plus I will scale a complex number by root 2 and rotate it in an anti-clockwise direction about the origin by pi upon 4. Now, to do the opposite, we would need a scaling of 1 upon root 2, it's the multiplicative inverse of that, and the additive inverse of the argument, so that would be negative pi upon 4. That would be a clockwise rotation of pi upon 4. So that's the complex number that would undo multiplication by 1 plus I. And that's what we were asked to find in part A. Now, part B asks us to convert this to Cartesian form, which would be easy enough. All we need to do is to find out what the cosine of negative pi upon 4 and the sine of negative pi upon 4 is. Now, we know that the cosine of pi upon 4 is 1 upon root 2, and the sine of pi upon 4 is also 1 upon root 2. But if we're in the fourth quadrant with a negative pi upon 4, in there we have the cosine being positive, so that's 1 upon root 2, and the sine being negative, so that would be negative 1 upon root 2 for sine negative pi upon 4. So that's minus I times 1 upon root 2. Now, when we multiply that out, 1 upon root 2 times 1 upon root 2 is 1 over 2. Root 2 times root 2 is just 2, minus, and the same, a half, for 1 upon root 2 times 1 upon root 2. So it's a half minus a half I is the Cartesian form of this complex number, which we have here in polar form. So part C says, can we derive this result without going through this polar form step? So let's just think about this. We've got a complex number, say Z1, and we multiply it by, say, Z2, and we're wanting to undo that multiplying by Z2. Well, we know that dividing by Z2, these cancel, and we're left with Z1. So what is dividing by Z2? Let's think about this a wee bit further. It's the equivalent of multiplying by 1 over Z2. So if we're looking at multiplying by 1 plus I, then to undo that, we would surely multiply by 1 over 1 plus I. So this is now an expression that we can easily simplify. We multiply top and bottom by the complex conjugate of 1 plus I. So on the bottom we'll have 1 plus I times 1 minus I, and on the top we'll have 1 times 1 minus I. So firsts, outsides, insides, last. The firsts give us 1. Outsides and insides cancel. The last two terms give us I times negative I, which is negative I squared. And of course I squared is negative 1. The negative of negative 1 is plus 1. So we end up with 1 minus I divided by 2. So let's split that up and divide each part of this numerator by 2. So we get 1/2 minus a half I. And that ties up with what we got before, but we've achieved that without having to go through this polar form. So that's Mr. Corsi signing out, and hope you enjoyed the video.